Is it visible?
Yes, sir.
Now, today we are moving to the unit 2, which is known as interpolation. Interpolation. Before going to start the interpolation, we have to know how to draw the graph, how to find out the sketch of the graph. That is very similar. Suppose when we have a set of points like this, x1, x2, etc., etc., xn, and x0 also. Similarly, corresponding values of x1, x2, etc., xn, corresponding values y0, y1, y2, etc., etc., yn, right? Or sometimes in terms of the function f of x0, f of x1, f of x2, like this. The problems points are given like this. These x0, x1, xn, etc., xn are these points are known as independent variables. These points are known as independent variables. Here we call these independent variables are also known as arguments. Also known as arguments. Right? By giving the values for x1, x2, x3 for any function y is equal to f of x, say, we will find out the values of y0, y1, y2, yn values. These are known as dependent variables or simply entries. Dependent variables are entries. These are called entries. Okay. Now the task is to find the function y is equal to f of x by taking the values of set of all these values. By taking set of all these values. That means these set of values satisfying the relation set of values satisfying the relation y is equal to f of x. Satisfying the relation y is equal to f of x. And suppose sometimes y is equal to f of x is not known. It is not given in advance. Y is and f of x is not known. F of x is not known. Now, if it is possible to find a simple function, if it is possible to find simple function pi of x such that the both f of x and pi of x are agree at all the set of the points. All the points satisfies these two functions. Is it right? Such that f of x and pi of x agree. F of x and pi of x agree at the set of tabulated values. At the set of above tabulated values. Above set of these two functions satisfies all the values of x1, x0 to xn, y0 to yn. Right? Here f of x is the relation and it is not known, and it is possible to find some other relation pi of x, other function pi of x, and these two functions satisfies all the points. Then the process of finding pi of x, the process of finding pi of x, the process of finding pi of x is called interpolation. Is called interpolation. It's called interpolation. Is it right? That is the way that we are defining the interpolation. And if pi of x is a polynomial, then the process is called polynomial interpolation. If it is a polynomial, it is known as polynomial interpolation. That we have to note down as the next point. If pi of x is a polynomial, if pi of x is a polynomial, then the process is called polynomial interpolation. Polynomial interpolation. It's called polynomial interpolation. E pi of x is called interpolating function. Pi of x is known as interpolating polynomial function. Here, pi of x is called interpolating function. That is the simple definition of polynomial, right? Suppose when we computing the values by using this function between x0 and xn, we are computing the unknown value of y by using this function pi of x between x0 and xn. That is called interpolation, exact interpolation. Suppose beyond that values, that means suppose x is less than x0 and x is greater than xn. Beyond that values, then it is known as extrapolation. Then it is called extra. అంటే మీ x0 xn మధ్యలో డిఫైన్ చేయగలిగితే then it is called interpolation. ఆ రెండు వాల్యూస్ మధ్య కాకుండా outside that values find out చేస్తే then it is called extrapolation. Then it is called extrapolation. That you have to note down the next point. Now, simple definition that we have to write here as definition. Computing the values for a tabulated function. Computing the values for a tabulated function at points not in the table. At points not in the table. This is very, very important. Not in the table is known as interpolation. Known as interpolation. Right? Now, note down the next point. Pi of x is known as interpolated values is known as interpolated values when this is very, very important. X naught less than x less than xn. X naught less than x less than xn. And extrapolated and extrapolated and extrapolated values when this is the condition x is less than x naught or xn is less than x. Both are same. X is greater than xn anna okate, xn is less than xn anna okate. Outside that interval, then it is known as extrapolated. Inside that interval, it is known as interpolated. Okay. And one more important condition or formula that we have to define here. Error in polynomial interpolation. Error in polynomial interpolation. Here we should not go through the derivation of this part. Simply we have to write down the error function formula. Error, right. It is given by E of x. How can you find the error? How can you define the error always? One is approximate value and other is exact value. That means the difference between the exact value and approximate value is called error. That is the simple definition. When you need to find out the absolute error means actual value modulus of actual value minus approximate value. Actual value minus approximate value. That is called absolute error. In the same phenomena, when you need to find out the error in the polynomial interpolation, that is given by f of x, that is the given function, and interpolate function pi n of x, difference between the exact function and interpolate function. One is f of x means that is exactly given function, and pi n of x is the interpolation function that we have to forming the function. Is it right? And is given by that is equal to x minus x naught, x minus x1, etc., etc., x minus xn into f power n plus 1 of xi. Xi means it is any point between x0 to xn by n plus 1 factorial. Or in other words, we write this that we have to write in the form of the product pi of x. This entire function that we have to write it known as pi of x or pi n of x, like that, into f power n plus 1 of xi divided by factorial of n plus 1. Here x naught less than xi less than xn. Xi lies between x naught and xn. X naught and x be the expression for find the error. Be the expression for finding the error. for finding error. This is the error in polynomial interpolation. Error in polynomial interpolation. Right? Now, shall I move the slide? Yeah. How can you define the error exactly? Error exactly we have to define as error. Simply we have to write down the definition. Simple values of the errors, something. Error is equal to exact value is equal to approximate value plus error. Exact value is equal to approximate value plus error. Plus error, and sometimes we are denoting this one as epsilon. Epsilon. Okay. The error may be defined as actual or exact values minus approximate values. Error may be defined as, simple definition, may be defined as exact values minus approximate values. Exact or actual. Actual values minus approximate values. This value is very negligible value, a small value. That is the difference between the actual and approximate value is called error, right? Now, some absolute error. Types of errors, so many types of errors are there in which we have to write down some value. Absolute error. But actually, this is not in our syllabus, but you have to know something related to the errors. Absolute error is equal to modulus of x minus xa. X is called exact value. Xa is called approximate value. A stands for approximation. X is exact. Xa is approximate value. Xa is approximate. That is absolute error. And one more the error is the relative error. Relative error. Relative error is defined as absolute error by exact error. Absolute error by exact error. X minus xa by x. This is relative error. Absolute error by exact value. And what is percentage error? Percentage error. That is equal to relative error into 100. That is x minus xa by x into 100. X minus xa by into 100. These are the simple some errors related to that, and so many errors are there. Inherent errors, some errors that is not in our syllabus that you have to note down. Inherent errors. Then rounding error. This మీకు తెలుసు rounding error అంటే rounded to the some value. Rounding error. Then next truncation error. Truncation error. truncation error, etc. ఇవన్నీ కూడా ఉన్నాయి. Okay. Now again we move into our original topic, finite differences. Finite differences. Finite differences. Finite differences. Finite differences deals with the changes in the takes place in the values of the function due to finite changes in the independent variable. అంటే ఏమి కరస్పాండింగ్ వాల్యూస్ x లో వాల్యూస్ కి చేంజెస్ చేస్తా పోతే కరస్పాండింగ్ వాల్యూస్ లో y లో కూడా చేంజెస్ జరుగుతూ వస్తాయి. వాటి యొక్క డిఫరెన్సెస్ ని వచ్చేసి ఫైనైట్ డిఫరెన్సెస్ గా డిఫైన్ చేస్తాడు. Forward again, finite differences are classified into three categories. One is forward differences, another is backward differences, and other is central differences. These are classified into three categories. One is forward, and the next one is backward, and the third one is central. We are defining the differences into three types. Suppose when actually we are defining x0, x1, x2 like this, etc., etc., etc. Instead of these values of x0, x1, xn, suppose we have to take x plus h, x plus, say for example, x plus h, x plus 2h, etc., etc., x plus nh. Here h is called the interval of differentiating. H is called the some fixed value that we have to increase in the independent variable, increase in the argument. Some fixed value that we have to increasing the values. Suppose for example, we are calling the numbers as 1, 2, 3, 4, 5 like that. What amount of interval that we have to increase means 1. ఒక్కొక్క దానికి ఒక్కొక్కటి యాడ్ చేస్తూ పోతే ఏమవుతుంది, మనకు 1 ఉంది స్టార్టింగ్ నంబరు, దానికి 1 0 ఉంది, దానికి 1 2 3 యాడ్ వచ్చాయంటే అర్థం ఏంటి, 1 నంబర్ ని యాడ్ చేస్తూ వెళ్తున్నాం. Is it true? That we are calling that as interval of differentiating. This h is known as interval. H, interval of differentiating. Or simply in other terms we are saying small increment. Increment అంటాం దీన్నే, a small increment. Sometimes in other words we call this one h బదులు మనం ఏమనొచ్చు, x లో చేంజ్ ను డెల్టా x అనొచ్చు, y లో చేంజ్ ను డెల్టా y అనొచ్చు. ఈ ఇంక్రిమెంట్ అని వచ్చేసి x లోను y లోను, x లో చేంజ్ ఇంక్రిమెంట్ ఈజ్ ఈక్వల్ టు డెల్టా x, y లో ఇంక్రిమెంట్ ఈజ్ ఈక్వల్ టు డెల్టా. Are you understanding? Very, very simple one. Okay. Now let us see the forward, backward, and first we have to write down the finite differences. Finite differences deals a single line. Finite differences deals with the changes that takes place in the value of the function due to finite changes in the independent variable. In the independent variable and argument in the independent variable. Okay, this is the simple information regarding finite differences. Right now, first one is forward differences. Forward differences. Now, before going to define the forward differences, let us see the table first of all. But observe this table. Suppose x is some x n is the arguments, y is the corresponding entries, y values, and right now this is the, say we call this one as delta x. We call this one as delta x. Right. Next, that is the first order, and delta square x. Then next, delta cubed x. Some depending on the values. Suppose we take the values of x is equal to x naught plus h. We call this one as x1 sometimes. Next, x2. x2, x0 plus 2h. x0 plus 3h. This is x3. This is x1. x4, x0 plus 4h. Right? x5, x0 plus 5h, like this. And y0, say we call this one as y0 or f of x0. This one is y1 or f of x1, y2 f of x3, y3 f of x3, y4 f of x4, and y5 f of x5, like this. Now delta x. Delta x means, that is, we call this one delta, not in x, y, that we have to find out in y's. Therefore, we have to write y's here. Right? These are the values. Sorry. Like this. Right? Now this is the delta y, delta square y, delta cubed y, and delta power 4y. That means that we need to find out the change in these two. That is delta y. y1 minus y0, simply. y1 minus y0. Difference between y1 and y0 is called delta y0. This we call this one as delta y0. We call this one as delta y. And again, difference between these two, y2 minus y1. y2 minus y1. We call this one as delta y1. Delta y1. And again, difference between these two, y3 minus y2. We call this one as delta y2. Delta y2. And again, we find the difference between these two, y4 minus y3. We call this one as delta y3, and difference between y5 minus y4. We denote this one as delta y4. These delta y0, delta y1, delta y2, delta y3, delta y4, etc., are called first forward. Are called first forward differences. Are called the first forward differences. Now we have to write down the definition as first forward differences. Right? Let y is equal to f of x. Let y is equal to f of x be the given function, be a function. Right? Let y0, let y0, y1, y2, etc., yn be the set of values of the function, be the set of values of the function y is equal to f of x. Be the set of values of the function y is equal to f of x. And let we are defining the delta x is equal to h, which is known as the interval of differentiating. Interval of differentiating. Interval of differentiating. We denote the small increment in x. We denote the be the small increment be the small increment in x. Be the small increment in x. Now, the first finite differences. The first finite differences of the function y. Shall I move the slide? Shall I move the slide?
Yes, sir.
Of y is defined by delta y. Delta y means change in x minus change in y. That is delta of f of x. Delta y and delta y and f of x. That we have to define as delta of, or you have to write down this clearly. That is equal to f of x plus in terms of delta x minus f of x. Or in other words, simply we have to write f of x plus h minus f of x. ఇది ఎక్కడో చూసినట్టు మీకు గుర్తుంది ఇంటర్మీడియట్ లో గుర్తుందా? Are you observe this one? First principles of derivative. Limit as h tends to 0, f of x plus h minus f of x by h, if it exists, is called the derivative. That is nothing but limit as delta x tends to 0, delta y by delta x, if it exists, is called the derivative of y with respect to x. Are you observing? Gurtunda? Say yes or no? Huh?
Yes, sir.
పలకండి మా. This is the delta y simply.
Yes.
Okay, no problem. Now the differences. What are the differences? Actually, y1 minus y0, y2 minus y1, etc., etc. yn minus yn minus 1 are called the first forward differences. First forward differences. First forward differences, and they are denoted by delta y0, delta y0, delta y1, comma, delta y2, etc., etc., delta yn minus 1 respectively. Right? We have write down the clearly like this. This is very, very important. Delta y0 is equal to y1 minus y0. Delta y1 is equal to y2 minus y1. Delta y2 is equal to y3 minus y2, and so on. In terms, delta yn is equal to yn plus 1 minus yn. This is the general part. And here, delta, the symbol delta is called difference operator or forward difference operator. Here, the symbol delta, is called forward difference operator. Is called difference operator or sometimes forward difference operator. Forward difference operator. Right? These are all are called in the first degree. Therefore, we call this one as first forward difference operator. Similarly, we define the second forward difference and higher order forward differences that we have to see. Next point. The differences of the first forward differences. The differences of the first forward differences are called second forward differences. And are denoted by delta square y0, delta square y1, etc., etc., delta square yn, like this. Now let us see the formula for this one. Delta square y naught is equal to delta y1 minus delta y naught. Delta y1 minus delta y naught. అంటే మన టేబుల్లో సి అబ్జర్వ్ ఆల్ ఆఫ్ యూ వన్స్ అగైన్. ఇక్కడ ఈ రెండింటి డిఫరెన్స్ వచ్చేసి సెకండ్ అంటే ఏమి, దిస్ ఇస్ కాల్డ్ delta y1 minus delta y naught. This is called second forward differences. Delta square y naught. ఈ రెండింటి తీసుకుంటే delta y2 minus delta y1. This is called delta square y1. And again difference these two. Delta y3 minus delta y2. This is called delta square y2. And this one like this. Okay, now let us see here. This one, and delta square y1 is equal to delta y2 minus delta y1, etc., etc., etc. Delta square yn is equal to delta yn plus 1 minus delta y. This del square is known as second forward difference operator. Del square is known as second forward difference operator. Similarly, we can easily find out under higher order differences. Okay. Similarly, we can easily form the higher order difference operators. Differences. Okay. Now, let us see the simple table related to the forward difference table. Forward difference table. Okay. Now here, for simplicity, I can write only one variables like this: x naught, x values, y values, first forward, second forward, third forward. Okay. Right. Chale. Now x naught, x1, x2, x3. లేదు తగ్గించేసి పెంచుదామా, x4 x5 వరకు తీసుకుందామా. దెన్ we have to write like this. దగ్గరగా రాస్తాం. y values, y naught, y1, y2, y3, y4, y5. I can use different colors for very easily identified. This is First forward. Delta y0, delta y1, delta y2, delta y3, delta y5. This is first forward. Then again change the color for second forward. Del square y. This one. Del square y0, del square y1, del square y2, then del square y3. That is second. Next, third forward. Delta cubed y. Delta cubed y0, delta cubed y1, delta cubed y. Next, fourth forward. Delta power 4. Delta power 4 y0. Delta power 4 y1. Delta power 5. Delta power 5. So this is the forward reaction. Therefore, we call this one as forward like this. Forward. పైన నుంచి వస్తుంది కాబట్టి ఫార్వర్డ్ అంటున్నాము. అదే కింది నుంచి తీసుకుంటే బ్యాక్వర్డ్. అంతే తేడా. బ్యాక్వర్డ్ అన్నప్పుడు డెల్టాను వచ్చేసి డెల్ గా రాస్తాం, నాబ్లా గా రాస్తాం. దిస్ ఇస్ వెరీ వెరీ ఇంపార్టెంట్. The above table is called diagonal difference table. Note down some points. The above table. Nana, voice Jagrata. Phone. The above table is called a diagonal difference table. Diagonal difference table. The first term y0 is called the leading term. The first term y0 is called the leading term. Is called the leading term. The differences paivanni leading differences center. The differences delta y0, delta square y0, delta cubed y0, etc. are called leading differences. Leading differences. This is the first forward difference table and related information regarding this one. And we have to do tomorrow backward and central, and then we have to study some relations between these three also. Okay. Thank you. I will stop here today. Any doubts?
Dependence.